to replace here, 2 plus 2 here. So how to obtain that one? So let us plot the waveform for the h of tau first and h of t minus tau in order to let us plot the waveforms here. So right, so h of tau is nothing but u of t plus tau here. So u of t plus 2 is nothing but the signal will be shifted towards the u of t will be shifted towards the left side by 2 units here. So that will become u of t plus 2. So that is from -2. So from -2 up to the infinity will be there. So this one you are going to call it as the u of tau plus 2 here. U of tau plus 2. So this is the time axis. The amplitude will be equal to 1. This is called as the h of tau. We can call here h of tau. Then next we want h of t minus tau. H of t minus tau. In order to get that one, what I'll do is first is I'm going to perform the shifting of the signal. I'm going to perform here towards the left side by 2 units. Okay. So first let me get the signal called h of tau plus t. So h of tau plus t means the signal will be shifted towards the left side by t units. So it has since already -2 is there. So for minus t will be added here. So this has become h of t plus tau will get here. H of t plus tau. It is having the amplitude 1. So -2 is there. For the -2, I'm going to add the minus t. I'm going to add. This has become h of minus t minus 2 here. Right. Now we are going to perform the. Now we are going to perform the reflection. We are going to perform in order to get the signal. So if you take the reflection, the signal will become the h of t minus 2 will get here. So if I take the reflection, the reflected signal will be equal to the. So this is a reflected signal. So it is a t plus 2 will get here, because since we are taking the reflection, both are minus, it will become t plus 2. So I don't know what's the value of the t here. So I'm going to call this one as a h of t minus tau. We are going to call here h of t minus tau. So this is tau here. The corresponding amplitude will be equal to 1. Since we don't know, I'm not defining the origin here. So just for defining the signal, we are using this one. So right. Then, so this is h of t minus tau. Next one is we have x of tau is equal to e to the power of -2 tau into u of tau. It's e to the power -2 tau into u of tau. So I'm going to draw that waveform. I'm going to plot it here. So this is x of tau is equal to e to the power -2 tau into u of tau. So that is u of t is nothing but it is starting from 0 to the 1 will be there, and e to the power of -2t is nothing but it's exponentially decaying signal. So we can plot like this. So this is an exponentially decaying signal. This is, we can call it as a x of tau. So it will be take the value like this. So from 0 up to the infinity, it will take the value. So this is a t is equal to 0. It is having the value 1. So it is e to the power of -2 tau. E to the power of -2 tau will take here. Here also you're going to take the same condition, set of conditions you are going to take, but only difference is integration you are going to use. There you are going to use the summation. Here it's a continuous time signal. There it was the discrete time signal here. So e to the power -2 is nothing but it's a exponential decaying signal. That's why we have t is equal to 0. It is having the value 1, and like it will become equal to 0 here. So done, right? You can see the video. Clarity is there. Clarity is there, right? Now let us take the cases here. Okay, case 1. What is the case 1? Can anybody tell me? So this is h of t minus tau, and this is x of tau here. So based on these two, we are going to take the case here. What is the first case? Similar to the discrete time convolution, here also you're going to use the convolution here. So what is the first case you're going to get? What is the first case? Anybody? So here t plus 2 is there, and here 0 is there. What is the first case? Anybody? So first case is non-overlapping condition here. The condition is that t plus 2 is less than 0 here. T plus 2 is less than 0. So take the first case is t plus 2 is less than 0. I'm not going to use equals. It is less than 0 because there is no overlapping we need to see here. So this implies that. So t can take the value less than the -2. It will take here. T is less than -2. So there is no overlapping. So there is no overlapping of the sequence. Therefore, y of t will be equal to the 0 will get here. Y of t will be equal to 0 for t is less than -2. For t is less than -2, y of t is equal to the 0 will get here. And my voice is audible, right? Are you following? Are you following?
Yes, sir.
Okay, fine. So you got the 40 is less than 0. So for the non-overlapping condition, it is equal to the 0 will get here. So now let us take the next condition. What's the next condition? What's the next condition? T plus 2 is greater than or equal to 0 here. So both are infinite division sequence. So T plus 2 is greater than 0. Greater or equal to 0 means it can take any overlapping condition it can take here. So take the case 2. So case 2 is T plus 2 is greater than or equal to 0. If you are not understanding, ask me, because easily RMC you can score the marks. So 20 marks of RMC you can score just plotting the waveforms and taking the equation. That's it here. Nothing else you need to do here. Okay. So case 2. So T plus 2 is greater than or equal to 0. So this is a T plus 2. We are going to move outside this one. So I'm going to plot the waveform for the x of t. I'm going to plot the waveform for the x of t as well as h of t minus tau. So first let me plot the x of t here. So x of t will take the value like this. So this is the tau axis. This is x of tau. So this is x of minus 2t will get here, and amplitude 1 at t is equal to 0. Next, I'm going to move t plus 2 after the greater than or equal to 0 here. So let us take this is t plus 2 here. So this is h of t minus tau. So this is the tau. This is the t plus 2. This is 0. Okay. This is 0. So we need to take the product of these two here. When you take the product of this one, so below this one 0, so it is having the value 1. 0 into 1 is nothing but 0 will get here. And this is exponentially decaying, and this is having value 1. So when you multiply both here, so exponentially decaying with 1, the same waveform will get here. So the waveform will be, so like this will get here. So this is 1. So this is a product of x of tau into h of t minus tau. The product is going to be exist from 0 to the t plus 2. This value will be equal to the e to the power of minus 2 tau will get here, e to the power of minus 2 tau from 0 to the t plus 2. Done, right? Any doubts in this one? So this is actually very easy, very simple concept here. So if you know the concept here, you can enjoy the problems. So let us write the formula. So y of t is equal to, so from 0 to t plus 2, if you want, you can write the generalized formula, minus infinity plus infinity x of tau into h of t minus tau into d tau. So let us change the time interval. So the time interval is from 0 to the t plus 2. The magnitude of the product of that one is e to the power of minus 2 tau into d tau. So you know the integration of e to the power of minus 2t, that is e to the power of ax is e to the power of ax by a. So the limit is from 0 to the t plus 2. Substitute the limits here. The upper limit is e to the power of, so t plus 2 will get here, minus 2 into t plus 2 minus e to the power of 0 divided by minus 2. So e to the power of 0 is nothing but 1 minus e to the power of, so when you multiply with the minus here, it will become minus e to the power of minus 2t. 2 into t plus 2 will get here, 2 into t plus 2. So divided by 2. This is for the t's. Okay, so t plus 2 is greater than or equal to 0 means t is greater than or equal to the minus 2 here. T is greater than or equal to the minus 2. So this is the answer we got here. So let us summarize. Therefore, y of t is equal to the, so since two values is there, so it is 0 for t is less than the minus 2, and it is 1 minus e to the power of minus 2 into t plus 2 divided by 2. So for t is greater than or equal to the minus 2, t is greater than or equal to minus 2. So t is greater than or equal to minus 2 means you can express this one in terms of the unit step function also you can do express here. Unit step function also you can do express here. So that is u of t is greater than or equal to minus 2 means it can take the value. Minus 2 is less than or equal to t is less than the infinity. So this will become u of t plus 2 here. So y of t is equal to 1 minus e to the power of minus 2 into t plus 2 divided by 2. So this entire thing can be multiplied by, so you can express as a unit step function u of t plus 2 you can express here. Done. Any doubts? Any doubts in this one? Any doubts?
No, sir.
Understood, right, everyone? Okay.
Yes.
So let me go. If you have any doubts, ask me now itself. Okay, so let us go for the next problem. Take the problem number 2. Find phi of t is equal to x of t convolution with h of t given x of t is equal to cos pi t into u of t plus 1 minus u of t minus 3 h of t is equal to u of t. Done. Okay. Now let us plot the waveform for this one. So let me write the convolution formula. So y of t is equal to, so among these two, you can see h of t is the simplest one. Let us introduce the shift in this one here. So y of t is equal to x of t convolution with h of t. So the formula is the integral from minus infinity to the plus infinity x of tau into h of t minus tau into d tau. X of tau into h of t minus tau into d tau. Okay. So here we have the waveform for the x of t is there, which is cos pi t into u of t plus 1 minus u of t minus 3 here. Okay. So u of t plus 1 means it is going to start from 1, and u of t minus 3 means so from 1 to minus 1 to the plus 3 it will be there here. Minus 1 to plus 3 will be there. So that multiplied by the cos signal. So you are going to get the cos signal from the minus 1 to the plus 3 you are going to get here. Is it correct? Is it correct, right? So you're going to get the cos signal from minus 1 to the plus 3 will get here. So this is u of t plus 1 means there is a 1, it is there from minus 1 here, and at 3 both will get cancelled. So up to 1 to minus 1 to the 3 will get here. So multiply by the cos signal. So x of tau. So x of tau I'm going to define like this here. So it is cos pi tau into u of tau plus 1 minus u of tau minus 3. Okay, so the cos signal is going to be exist from minus 1 to the plus 3 here. So this is the cos signal. So I'm going to draw the cos signal like this here. So I'm not going to draw exactly as per this one. So this is minus 1. So just I'm going to draw the waveform like this here. Minus 1. So this is x of tau we can consider, and it is going to end at the plus 3. It is going to end here. So this is the tau axis. The maximum value will be 1 and minimum value will be minus 1 for the cos signal. You know this one, cos 0 is plus 1 and cos pi will be minus 1 will get here. So this is the x of tau will get here, cos signal. So right, if you want, I'll define here. So u of t plus 1 minus u of t minus 3 is nothing but it is having the value 1 from minus 1 is less than or equal to t is less than or equal to the plus 3 here. So right, you can able to see, right? Okay, so that is u of t plus 1 minus u of t minus 3. We are going to get from 1 to minus 3. Done.
Yes, sir.
Okay, so next we have u of t. So I'm going to fix this signal here. So u of t, I want h of tau. So this is for the signal u of t plus 1. I want h of tau. H of tau is nothing but u of tau. Okay, I want h of t plus tau. So from that one, next h of t plus tau is nothing but u of tau plus t here. Okay, so and also I want h of t minus tau. So this is nothing but u of t minus tau will get here. So first u of tau is there. So let me plot u of tau. So u of tau is nothing but from t is equal to 0. So u of tau. So from t is equal to 0 to infinity is there. So u of tau plus t means it is going to be exist from the. So it will be shifted towards the left side here. Already we know that one. So from minus t, it will be shifted here. We don't know the value of that one. So this is h of t plus tau. Next one is we want h of t minus tau. Means we need to take the reflection. When we take the reflection, we'll get like this here. So since we don't know the value of t, I'm going to just define like this. So this is h of t minus tau into. So this is the tau axis here. This is the tau axis. Okay, the corresponding value is 1 here. The corresponding value is 1. So we got this is h of t minus tau we got, and x of tau we got here. So x of tau is defined from minus 1 to the 3, and this is defined from t to the minus infinity. It will be defined here. So done, right? So if you plot the waveforms, so next simple is defining the cases. So it's very simple. You can do it easily. You can do it here. So since we know how to do for the discrete time signal, the continuous one we can do it very easily. We can do it here. Done. Okay. So what is the first case? Can anybody tell me? Case 1. What's the case 1? Can I get the answer? Case 1. What is the answer? What's the value of t here? Case 1, which will take here. Non-overlapping case. Anybody? Can I get the answer? Anybody tell me what is the value of that first case? So no answer.
0.
Yeah.
T less than 0, sir.
No. T. We need to compare with respect to the x of tau. We need to compare the time index of x of tau, defining from minus 1 to the plus 3. Okay, means t should be less than the minus 1 here. T should be less than the minus 1 here. That's the first case here. See, if you are not serious now, okay, if you're not serious in this subject, if you're not regularly practicing the things, later it will be very much difficult for you people. So case 1, when t is less than the non-overlapping condition. So t is less than the first time limit of the other sequence here. So t is less than minus 1. So no overlapping. So there is no overlapping of the waveform. So therefore, y of t is equal to 0 for t is less than the minus 1 here. Y of t is equal to 0 for t is less than the minus 1. Done. So are we getting right? So for y of t, it is 0. What is the second case? What is the second case? So the waveform for the y of t is here, x of tau and h of t minus tau is here. What is the case 2? What is the case 2? So x of tau is defined from minus 1 to the plus 3, and this is h of t minus tau. So t can take any value between the minus 1 to the 3. It can take any value here. So t is greater than minus 1 and less than or equal to the 3 here, less than or equal to 3. So if I'm not getting the answer, it means that you're not practicing the problems. You're not practicing the problems in the convolution sum. Convolution, you not practice the problem. That's the meaning. Okay. The problems, what I'm teaching, if you are concentrating in the class, you will understand. If you're not getting, you can ask me the doubts. But later, if you're not going to practice today on the day itself, so in the final exam, really, it's very difficult for you people to solve the problem without practice. You can't do it. That's from my experience. And also one more thing, if anyone got fail in the signal subject, subjects in the beginning, okay, so it's very difficult to solve, very difficult to pass rather than the regular semester. Right, so keep this thing in mind and practice the problems regularly. So take the case 2. Case 2, it will take. So t is greater than minus 1. So when t is greater than or equal to minus 1 and t is less than or equal to the 3. T is less than or equal to 3. So let us plot the waveform for the x of tau. So x of tau, this is the value which is going to be from the minus 1 to the plus 3. So this is x of tau, so -1 to the 3. So this is tau, and this h of tau, t can take the any value between the -1 to the 3. So I'm going to keep somewhere here. So this is the t we are going to get here. T. So assume this is nothing but h of t minus tau. So this is having the amplitude 1 here. So this is assume somewhere will be -1 will be there here. So this is -1 up to the +3, having the amplitude 1. So when you take the product of this one, the product is going to exist. So here 0 is there after -1. So here 1 is there. So 0 multiplied 1 will be 0 only. So from -1 to t, this will multiply by some waveform. You're going to get the same waveform you will get here. So let us plot this one. So the waveform will be something like this. We'll get here. So up to t, assume t will be somewhere here. So this is a t. So from -1 to t, we are going to get here. So this is a product of x of tau into h of t minus tau. X of tau into h of t minus tau. From -1 to t, the product is going to exist here. Okay. So let us define the mathematical expression. So y of t. So write the integral formula. So x of tau into h of t minus tau into d tau. So this is cos pi t. This is cos pi t. So y of t is equal to, change the limits from -1 to t. So integral from -1 to the t. The product of this one is nothing but it's a cos pi t into d tau. So cos pi tau into d tau. Cos pi tau into d tau. Okay. So you know the integration of cos is nothing but, or the integration of cos? Cos ax.
Sine, sir.
Yeah, sin ax by a, right? So
Yes,
it is sin pi t. Yeah, so sin pi t by pi. The limit is from -1 to the t. -1 to the t. Let us substitute the limit here. So y of d is equal to, so sin, so this is pi tau here, not t, it's a tau here. It will become sin pi t minus sin pi divided by pi will get here, divided by pi. So sin pi, which is nothing but sin 0, no, sin 180 degree, sin 0 is nothing but 0 here. And sin pi t is pi t only will get here because we don't know what's the value of t here. Okay, so therefore y of t will become equal to the sin pi t divided by pi. So the time is, so t is greater than -1 and less than equal to 3 here. So it is -1 is less than or equal to t, less than or equal to the 3 will get here. So -1 is less than or equal to t, less than or equal to 3 will get. So this is the time index here. This is the time index. So sin pi t by pi. So from -1 to the 3. Any doubts? So what are the answers you're going to get? You put in the circle here. So there is a marks for each and every step here. So you can able to see, right? So video clarity is there now. Done. Okay.
Yes, sir.
Yeah, let us take the next case. What is the next case? Case 3.
T greater than 3, sir.
Yeah, very good. So t is greater than the 3 here. So t is greater than the 3. So t is greater than the 3 means, so the way this is moving outside the 3 here. So let us plot the waveform. So I'm going to plot the 3 waveforms. So from -1 to the 3 it will be there. So this is 3. So -1, and this one t is taking the value greater than 3. Okay. So this is somewhere 3 will be there. Somewhere -1 is there. This is the value 1. So this is h of t minus tau. So this is the tau axis. This is the tau axis. This is x of tau. So when you take the product of this one, so from -1 to 3, that signal is defined. This is defined for up to -infinity. So when you take the product is going to exist from only from -1 to the 3. So the waveform will be exist from -1 to the 3, somewhere like this. So this is the product of x of tau into h of t minus tau. Okay, so after t, so after 3, there is no waveform. So it is so we get 0 here. You can see the waveforms. Done. Okay. Now let us write the formula. So the signal will be defined from -1 to 3 here. So you can write, so y of t is equal to, so integral from -1 to 3, I'm directly substituting here. So it is the cos pi t, because 1 multiplied by, so this one is cos pi tau into d tau. So the integration of cos is, it's a sin pi tau divided by pi. The limit is from -1 to the 3. Substitute the limit here. So y of t is equal to, so it is sin 3 pi minus sin pi, so sin minus pi here. So t tau is equal to -1, sin minus pi. So divided by pi will get here. So divided by pi. Okay, so I think in the previous problem you taken the limit -1, no? So it is sin minus pi here in the previous problem. So still the answer is 0 only. No problem in the previous one. So yeah, it's t is equal to -1 means, so minus pi will get here. Still the answer is same, correct? So yeah, sin 3 pi is nothing but it's a 0 only, because sin pi, sin 0, sin pi, sin 2 pi, sin 3 pi, everything is 0. Even sin pi is also 0 here, so we'll get 0 here. So this is for the case t is greater than 3. T is greater than 3, so this will become equal to 0. So let us define the values here. Let us define the values. So what shall we define is, so summarize the values here. So y of t is equal to 0 for t is less than the -1, and it is equal to sin pi t by pi, sin pi t divided by pi. So from -1 is less than or equal to t is less than or equal to the 3, 0 for t is greater than the 3. Okay, so this answer we got here. Then any doubts in this problem? Video clarity is there, right? Okay. Let's take some different kind of problem here. Okay, so take find the convolution of the two. Okay, you can take simply find y of t is equal to x of t convolution with h of t. X of t convolution with h of t. So y of t is x of t is nothing but, so it is t plus 2t square. Okay, so from u of t plus 1 minus u of t minus 1 and h of t. So this will be equal to the 2 into u of t plus 2. 2 into u of t plus 2. You can see, right?
Yes, sir.
Okay. Okay, so now let us define the terms here. So we know that u of t plus 1 minus u of t minus 1 is nothing but, so it is having the value 1 from the -1 to the +1 here. So it is having the value 1 from -1 is less than t is less than or equal to the 1 here. T is less than or equal to 1. And the t plus 2t square is nothing but, so when we substitute that one, so it will be at t is equal to -1. T is equal to -1, it is -1 plus 2 into -1 square is nothing but +2 only. So it will become 1 only. 1 only it will become here. So we can define x of t like this here. X of t is equal to, so t plus 2t square. So from -1 is less than or equal to t is less than or equal to 1. So I'm going to plot the waveform for this one here. So it is a 2t square plus 1, t plus 2t square here. When I substitute t is equal to -1, I'm going to define the take the t different time intervals I'm going to take here. So let me plot the waveform for the x of t. So this is t at t is equal to -1, t is equal to 0, and t is equal to +1 here. When I substitute t is equal to -1 here, so -1 plus 2 into -1 square is nothing but +1 here. So -1 plus 2 will become 1 here. 1 for t is equal to 0, it will become 0 here. It will become 0. substitute t is equal to 1. So it is 1 plus 2 into 1 is nothing but 1 only. So it will become 3 here. So this is 3. So we can plot. So join the waveform. So this is the waveform you're going to get here. So you can draw it as a smooth curve. You can draw it here. So this is the waveform for the x of t or x of tau you're going to get here. Done, right? So you can draw it as a smooth curve. So this is the x of t or x of tau, we can call it here. So it is t plus 2t square from -1 to the +1. Then similarly, we have h of t. So h of t is equal to 2 into u of t plus 2. So this is defined from, it is having the value 2 from -2 to the less than t less than the infinity here. So we can plot the waveform for that one. So from -2, so this is h of t. So from -2 up to the infinity, it is having the amplitude 2 will be there here, 2. Got it, right? You can see these waveforms. Done? Okay. So
Yes,
now,
sir.
okay. Yeah, so now let me write the formula for the convolution. So among these two, the simplest one is h of t. Let us introduce the shift in that one. So we'll consider the formula for y of t. Y of t is nothing but, so x of t convolution with h of t. So let us write the formula. So integral from -infinity to +infinity, x of tau into h of t minus tau into d tau. H of t minus tau into d tau. So right. So we have x of tau. So x of tau is equal to, we have this one. So it is tau plus 2 into tau square. So even if you write, no problem. If you not write also, no problem. So it's less than or equal to 1. And we want h of t minus tau. So first let us plot h of t, already plotted here. Let us plot h of t plus 2 here. So h of t plus tau I'm going to plot. So this signal will be shifted towards the left side by, again, my t units here. So it has become, so -2 minus t will get here, -2 minus t. So this is called as a h of t plus tau, we are going to call here t plus tau. T plus tau. Now we want h of t minus tau. Let us take the reflection. So as we did in the first problem, let us take the reflection. So we got this one. So since we don't know the value of t, so I'm going to write as t plus 2 here. So I'm not going to define the origin. So this is called as a h of t minus tau. T minus tau. The corresponding amplitude will be equal to the 2 we'll get here. So this corresponding amplitude is 2 here. 2. And we have the waveform for the x of tau here. So x of tau I'm going to write. So here, so from -1 up to the 3 it will be there. So this is x of tau. So from -1 up to the 1. So this is 1, this is 3. So you got the waveform. This is h of t minus tau, and this is x of tau. So let us define the cases of overlapping and non-overlapping condition. Let us do it here. So what's the first case? What's the first case?
T plus 2 -1, sir.
T plus 2 is
T
less than
less
-1.
than
Less than
Yeah,
-1.
Less than -1. Very good. Excellent. Okay. So t plus 2 is, so this is a non-overlapping condition. T plus 2 is less than the -1. So less than -1 means, so you can send 2 that side here. So this implies that, so t is less than the -3. T is 2, if you go that side means plus 2 will become -2. So -3 here. So no overlapping. No overlapping. So therefore, y of t is equal to the 0 for t is less than the -3. For t is less than the -3, it will be equal to 0. Done. Okay. So next, let us define the next case here. What is the next case? So I think everyone got with the case 1. So no doubts. So see, in the convolution sum, we are solving only one problem. We are solving per class. Now we can able to solve 3 problems because you know the concept here. Okay, so if you practice the problems, still you can solve the problem faster than me also, you can do it here. But only thing is that you should practice the problem. What's the next case? What's the next?
T plus 2 greater than -1 and T plus 2 less than 3.
Yeah, very good, excellent. So, okay, so T plus 2 is greater than -1, less than 1 year. So when T plus 2 is greater than -1 and T plus 2 is less than the plus 1 year. T plus 2 is less than the plus 1. Okay, so we can move the T plus 2 anywhere between these conditions here. So let me plot the waveform for this one. So I'm going to plot on the same axis I'm going to plot. So this is -1, this is okay. So this is x of tau. So defined from -1 to the +1. So this will become like this. Okay, so this is 1, this is 3, and I can move T plus 2 between somewhere here. So this is T plus 2, assume like this here. So this is -1. So this is h of T minus tau. So this is tau. This is T plus 2 here. The product will encounter. So 2 multiplied by this one, 2 into 1 will become 2 here. 2 multiplied by 0 will be 0. So the product will be somewhere like this. So 2, 0, somewhere like this will get here. So this is x of tau into h of T minus tau. This is tau. So from -1 to the T plus 2 here. T plus 2. Let us see the value in the product. Let us see it here. Okay, so from -1 to the T plus 2, the product is going to encounter. So you can see T plus 2 is here. So the product will be exist from -1 up to the T plus 2. So since it is 2 is there here. So 2 is this value here. Amplitude is 2 here. So 2 multiplied by 1 will be 2 will get here. So we are not worried about the amplitude because we can define the mathematical expression. We can define it here. Let us see the waveform. We can define the waveform like this here. Okay. So now the convolution sum. So y of t is equal to, so integral, let us write the generalized formula. So h of t minus tau into d tau. So x of tau is nothing but it is a tau plus. So we'll get here. Let's change the limits. Let us change it here. So from -1 to the t plus 2, the value of x of tau is, so it is tau plus 2 tau square, tau plus 2 tau square. The value of h of t minus 2 is nothing but it's a 2 here into d tau. The corresponding this amplitude is 2 here. Let us integrate. The integration of tau is nothing but it's a tau square by 2, right? The integration of t to the power of n is t to the power of n by n plus 1, right? Correct? Is it correct?
Yes, sir.
Okay. So it is tau square divided by 2. The limit is from -1 to the t plus 2 plus the integration of 2 tau square is 2 tau cube divided by 3 from -1 to the t plus 2. That is apply the limits of the integration. Tell me the answer, how much you'll get here. Let us apply the limits of the integration. So I think you have taken. Okay, so apply the limits of the integration and you tell me the answer, how much you'll get. Do apply and tell me the final answer, simplified answer. Simplify it and tell me. So that's the expression for the y of t will get here. Do simplify. Can I get the answer? So do integrate this one. So already we have done the integration of this one. Substitute t is equal to t plus 2 the whole square divided by 2. So 2 gets cancelled here. Next t is equal to -1 means it will become +1. So it will become t plus 2 the whole square plus 1 will get here. And this is 2 into t plus 2 the whole cube divided by 2 by 3. So what's the answer you got? So this is from t is plus 2 is greater than minus 1 and t plus 2 is less than the plus 1 here. So t plus 2 is greater than minus 1. So this will become t is greater than or equal to, we can take here, greater than or equal to minus 3. Other one is t plus 2 is less than or equal to the plus 1. So t is less than or equal to the 1 minus 2 minus 1 here. So we can take minus 3 is less than or equal to t is less than or equal to the minus 1 here. So what is the answer you got? Can you get the answer? Anybody? What's the answer? You want me to solve? So no reply. So it is t plus 2 the whole square minus 1 the whole square, it will become. So it is 1 only. So divided by 2 plus this one is 2 by 3. 2 by 3 into, so t plus 2 the whole cube. So t plus 2 the whole cube. Okay. Minus, so minus 1 cube. So it is nothing but minus 1 divided by 3 will, okay, minus 1. That's it here. So continue to do simplification. So it is 2 will get cancelled here. So this will become t plus 2 the whole square minus 1. So this will become 2 into 2, it will become plus 4 by 3. 4 by 3 into t plus 2 the whole cube. Okay, so minus into minus will become plus 1. So 2 by 3. So here minus 1 is there here. So I forgotten minus 1. Okay, so continue to the simplification of this one. So y of t is equal to, so it is t plus 2 the whole square plus 4 by 3 into, so t plus 2 the whole cube. So 2 by 3 minus 1 is nothing but you can take the 3 as LCM here. So minus 1 by 3 will get here, minus 1 by 3. Done everyone? Done, right?
Yes, sir.
Answer is correct. Okay, so this is from minus 3 is less than or equal to t less than or equal to the minus 1 here. Check the answer. Okay, then take the last case. So I'll take only 1 minute. I'll take here. You can do the simplification. So the last case is, okay, so we have written the waveform. So the next one is t plus 2 is greater than the 1 it will take here. So case 3 we can take here. Case 3. So case 3 when, so t plus 2 is greater than, already equals we are taken here. So greater than 1 let us take here. So greater than 1. So these waveforms just I'm going to copy it and paste it here. So from minus 1 up to the plus 3. So this is x of tau. So this, are you following or simply sitting? Okay, switching on the phone and leaving. So t plus 2. So this is 2 here. So this is h of t minus tau. So assume somewhere here 1, assume somewhere here minus 1 here. So when you take the product of this one, so the product will become, so 2 to the, so it will become 2 and 6 here. So this is the product will become here. So from minus 1 to plus 1 tau. Okay, so we can define, so y of t will become integral from minus 1 to the plus 1. So the product of this one is 2 into, so it is a tau plus 2 tau square into d tau will get here. So do integrate. So if you are going to integrate this one, so 2 is a constant, the integration of tau is nothing but it is a tau square by 2. The integration of this one is 2 tau cube divided by 3. The limit is from minus 1 to the plus 1. So apply the limits, get the answer, summarize the answer here. Okay, so do evaluate this one. Done? Done, right? Any doubts? Okay, so in the next class, let me take with some more different kinds of problems. So we have taken, one is the finite duration sequence, other one is the infinite duration we have taken here. So we've seen the 3 different kinds of problems. So let us take these things in the, continue with some more problems in the next classes. So give your attention. If you are switching on the mobile and if you are living like this in the exam, okay, so it's very difficult. So think about that one, think about your future, and you act accordingly in the class. Okay, so thank you everyone. Thank you for attending the class.
Thank you, sir.
Practice the problems regularly.
Thank you, sir.
Yeah, thank you everyone.